All right, let's talk EMI, electromagnetic interference, the silent killer of high-speed PCB performance, and a real pain in the backside to debug. As speeds increase and components get smaller, things get more crowded. Signals start interfering, and before you know it, you got yourself a real mess on your hands. We're talking data corruption, false triggering, and even FCC compliance failures. Not good. That's where EMI simulation comes in. It's like having X-ray vision into your PCB, letting you see exactly where those pesky electromagnetic gremlins are hiding before you even lay down a single trace. No more expensive and time-consuming rework later on. CST Studio Suite is our weapon of choice here. A powerful tool that lets us simulate and analyze EMI in a virtual environment. We can test different designs, tweak parameters, and optimize for the cleanest possible signal integrity, all before we go anywhere near a fabrication house. Trust me, this is a heck of a lot cheaper and faster than trying to fix it in hardware later. Bottom line, EMI simulation is essential for any high-speed PCB design. It saves time, money, and a whole lot of frustration. First things first, we need to recreate our PCB inside CST Studio Suite. This involves importing our design files, typically in Gerber format. Think of it like uploading the blueprints of your circuit board. Once those are in, we need to define the materials. What's your PCB made of? FR4. What about the dielectric constant? These details matter, people. Accuracy is key if we want meaningful results. Next up, we need to define the boundary conditions. This basically tells the software how the electromagnetic fields interact with the world outside our PCB. Are we talking free space, a metal enclosure? We need to be specific here. Finally, don't forget the meshing. This is how the software chops up our design into tiny little pieces for analysis. The finer the mesh, the more accurate the results, but also the longer the simulation time. It's a balancing act, people. Now it's time to pick the right tool for the job. CST Studio Suite offers a whole arsenal of solvers, each with its own strengths and weaknesses. For radiated EMI, we're mainly interested in the time domain solver or the frequency domain solver. The time domain solver is like a sledgehammer. It's great for analyzing transient effects in wideband emissions. It's like hitting your circuit with a short, sharp pulse and seeing what comes out the other end. The frequency domain solver, on the other hand, is more like a scalpel. It's precise and efficient, ideal for analyzing narrowband emissions. Think of it like scanning your circuit across a range of frequencies and looking for any peaks in emissions. Which one you choose depends on your specific needs. Need a quick and dirty overview? Time domain is your friend. Hunting down a specific frequency gremlin, frequency domain is the way to go. Section 4. Identifying the enemy. Defining excitation sources. No battle plan is complete without knowing your enemy. In EMI simulation, our adversaries are the sources of electromagnetic noise. These can be anything from high-speed clocks to switching power supplies. We need to tell CST Studio Suite exactly what kind of noise these sources are generating. Are they digital signals with sharp edges? Are they sinusoidal waveforms? What's the frequency? The amplitude? The more information we feed the software, the more accurate our simulation will be. Don't forget about common mode versus differential mode noise. This is important, folks. Common mode noise travels on both signal lines, while differential mode noise travels between them. We need to account for both. Section 5. Launching the attack. Running your EMI simulation. Alright, time to see what this thing can do. Hit that run button and let CST Studio Suite work its magic. This is where the software crunches all those numbers, solves those complex equations, and ultimately shows us where our EMI problems are hiding. Be patient. This might take a while. We're talking anything from minutes to hours, depending on the complexity of your design and the resources available. A good cup of coffee or tea is recommended while you wait. While it's running, keep an eye on the progress bar and any error messages that might pop up. Hopefully everything goes smoothly, but it's always good to be prepared in case something goes wonky.